For this next example, we're going to graph y is equal to 1/2 raised to the x power, and then also identify attributes for it. So let's go ahead and take a look at our a value. Our a value is 1 again because I don't see anything in this location, so it's the implied 1. But this time our b value is 1/2. So notice the relationship here. This was a 2 and this is the reciprocal of 2. So I want you to see what happens when we have that situation. So this is going to be a decay function instead of a growth function because b is between 0 and 1. So here's what I'd like for you to do. I want you to go to Desmos, grab some points like we did on the first example, come back here and plot them, and then come back to me and let's talk about our attributes. All right, so this is the function that you should have plotted, and I hope as you were plotting those points that you kind of noticed a pattern. Every positive x value that we had on this one has kind of a negative counterpart on this graph. They are exact opposites of each other because of that reciprocal. So let's go ahead and see what that does to our attributes. Well, our y-intercept is still going to be the same. It's at 0, 1. It's just that the graph does different things either side of that. So this is, again, my a value. So this point right here is 0, a. We can go ahead and identify our b value here. Remember, our b value was 1/2. So this point right here at 1 is 1, b, and this time b is at 1/2. Our asymptote is not changing. Y is still not ever going to get to 0. Our domain is kind of the opposite here. We are heading very straight to the right and very slightly to the left, but the result is the same, that we have a domain of all real numbers. Let's talk range, and our range is still not starting until we get just past 0. Once we get just past 0, our graph starts to appear. Remember, it's going to get infinitely close but never touch 0 because of the asymptote, so our range doesn't change either.